Hey team. If you're anything like me, then you probably drink a lot of wine. You may have noticed when doing your dishes or rinsing out your wine glasses, something happen. And I want to show you what that is, and then we'll talk about why it happens. So I have my wine glass here, and I like to drink red wine. So when I rinse them, notice that you can rinse and it's still pink, but hopefully you guys can see the color change. As it changes, it takes on a bit of a blue color, and I'm wasting a bunch of water, but now do you see it? The dark blue color happening now. You see it? Right? Let's get a little bit more water in there, and now it's definitely dark blue color, right? So that is because wine contains a pH indicator. What is a pH indicator? Well, a pH indicator is any molecule that indicates pH change by changing color or changing the color of the solution. And in red wine and a lot of other like juices from different fruits and even cabbage and whatnot, so like sauerkraut, anthocyanins is the name of that class of molecule, and these molecules are pH indicator. So this molecular structure here shows the overall defining characteristics of the class of molecules called anthocyanin, and it's mostly characterized by these central three aromatic units here. So benzene fused with another benzene-like thing connected to another benzene-like thing. Now, anthocyanins in particular are usually decorated or have a lot of other sugary type looking molecules here. So there's like a glucose here, and a lot of these, there are structures might have a sugar looking molecule on it. But really what does the pH indication is this bond right here. It's super, super cool what happens. So at low pH, this bond looks like this. So it's a double bond between a carbon and an oxygen, and that oxygen has 3 total bonds, so it's an overall positive charge right there. But at high pH, so if there's kind of floating around some free hydroxide or something like this, the hydroxide will attach or bond to that carbon, and then that breaks the double bond here. So no longer is there a double bond there. And what that means for our molecule is there's no longer this kind of continued resonance or continued conjugation. So when we talk about resonance and conjugation, it's what area can electrons move freely over within kind of like a pi structure. Yeah. So let's look at that chemical reaction or chemical change a little more closely. So this is our anthocyanin at very low pH, where we have that double bond to oxygen with a positive charge. And then as we add water and we change the pH from a low pH to a high pH, then we start to add, for a lot of the molecules in solution, we start to add hydroxide to that bond, which then decreases the amount of conjugation we have in this unit here. And what's key to know is that these conjugations in electrons in pi orbitals is what gives us visible light emission. That's what we can see things with color. So essentially, when we want to talk about something having color change in the visible spectrum, we're usually interested in electrons moving between different pi orbitals, okay? And as a result of that change in the number of electrons that can move between different pi orbitals, we have a change in color. So this here is the absorbance for the low pH red wine, right? And what we see is that in low pH red wine, the max wavelength absorbance is at 500 nanometers, right? That means that this red wine actually absorbs the most in the green color spectrum, meaning it emits the most in the red color spectrum. So we see red. However, as we start to add water, that max absorbance starts to shift from 500 to 600, but it's kind of a low grade shift. So it's not really anything too spectacular, right? But as a result, that shifts from absorbing mostly green to kind of medium absorbing a lot of different things, and then we see blue. And now we could actually take this one step further and we could add something more basic. We could change the pH to be something more basic. Now, I don't suggest doing this, but that would mean you could get something that would be greenish. Of course, wine is made of grapes, but there are other types of juices and stuff like blueberries, cranberries, currants, and even red cabbage that contain these anthocyanin molecules, and theoretically you should be able to do a similar experiment showing the pH change with the different types of juices. Okay, so for my final trick, I'm going to try this out with red cabbage. This is oh my gosh, what's it called? What's it called, guys? The German thing that tastes bad. Sauerkraut. This is sauerkraut that my husband made. And yeah, it's got red cabbage, and you can see it's that same red color. So we're going to give it a try. Okay, so I've got a little teeny bit. I tried to just get the liquid, but I got some clumps in there. So we will try and see if this works as well. And I will also, again, try not to waste a lot of water. But right, so you see the pink or red, whatever you want to call it. Okay, let's see, I'm trying not to waste water. Okay, it's starting to change a little bit. It's still pretty pink. It's verging on purple now. This might be easier to see because the wine, there wasn't much wine in there. Let's see if we can, oh, now look. See, look at that blue, the blue coming out, right? Okay, I should have just done this from the beginning, but I like wine too much. Right? It's gonna be the world's longest TikTok ever. But look at that. Okay, now let's try. This is like the world's worst made TikTok as well. Okay, wow, yes. Look. Okay, it was great. Yep. Look at that. Oh my gosh. I can't believe I did this. I'm pretty proud of myself. This was just a last minute idea. Okay. This is working. Okay. Look at this. Okay, so if you have kids at home, this would probably be, but you have to have kids and also sauerkraut, and I doubt kids like sauerkraut, so I'm sorry. I'm just so proud of myself. Look at that. I don't know if you can see, but it's cyan to me. Like, it's like kind of greenish to me. Maybe it's not coming through well. And don't eat this. Have I mentioned lately that you shouldn't eat soap? And don't inject it either. Can you see that? Okay, I'm so proud of myself. Okay, sorry. To me it looks green, but maybe it's not coming off on the camera. Wow. Okay, so that was your, I don't know what you want to call it, kitchen science for the day. Please drink responsibly if you